Good day. These are notes that you have to copy and they are not provided on a sheet, so if I go too quickly, just pause and get the information. We're looking at destruction of ozone by CFCs in the upper atmosphere, and this is indeed a catalyzed reaction. In the 1980s, there was great concern because there was a hole in the ozone layer, and ozone, which occurs, the ozone layer is in the stratosphere of the atmosphere. It absorbs harmful UV rays. And if you wipe out ozone, that means more UV rays can reach your surface and cause more damage to organisms. So this is looking at what's going on. We have regular oxygen, O2, and we have ozone, that's O3. So they have very different chemical properties. You're used to diatomic, ozone is triatomic. Now we've said CFC, and that stands for chlorofluorocarbon. And so you see carbon, 3 chlorines and fluorine. Remember, carbon wants 4 bonds around it. And these were commonly found, CFCs commonly found in refrigerants and plastic foam insulation. And even things like if for fast food, they didn't always put things in cardboard. They often put them in these sort of plastic foam things. And those would release chemicals, some of these CFCs, that were problematic. So let's see the mechanism for what was going on. So first of all, we've got to make our ozone. So we have oxygen, it gets hit by ultraviolet rays in the atmosphere, and it splits into 2. And these 2 oxygen atoms are going to be very reactive. They're very unstable. So then if another oxygen molecule runs into an oxygen atom, it can make ozone, which is quite a bit more stable. So that's just the making of ozone. That's separate from the mechanism that we're going to be looking at. Now, this talks about production of atomic chlorine. So here we have our CFC hit with UV rays, and now all of a sudden we have 2 very unstable things. Here we have carbon with only 3 things bonded to it, and we have this chlorine. And that chlorine is going to be a problem. So what we see is we made this chlorine, and this chlorine can now come along and attack ozone. So it hits O3, it makes OCl and O2, so we no longer have this ozone, and that ozone molecule doesn't exist anymore, so it can't block UV rays. Now the OCl gets together with an oxygen, makes O2 and Cl. Guess what? There's our catalyst. It was used in the first step, and it's regenerated in the second step. And it's been estimated that one of these chlorine atoms can help destroy 100,000 molecules of ozone. So that's really trying to emphasize the fact that it's reused. That's where, in this case, a catalyst is a big problem. So make sure you have all that copied down, and hopefully it makes sense.